In previous videos, we've written equations or at least verbal models for situations and then turned them into equations involving some unknown. And in this case, we're going to deal with things that involve unknowns, plural. That is, we're going to look at situations where we're going to write a verbal model that contain more than one type of variable. And so I think the best thing to do is just kind of look at an example and show you what I mean. As we go through this, I'll point out some important things to do as you read through a problem. So start with this. It says we plan on having only, consider that we're organizing an event. We plan on having only two types of ticket. We have adult and child. What we want to do now is write an equation with more than one variable that represents the revenue from the concert. Revenue is just, I don't want to say it's income because technically income is what you have left over after you say pay your bills, but revenue is all the money that you're going to make, okay? So the thing we want to do is we want to kind of underline important information here. Starting with this, we have two types of tickets, okay? And we have an adult ticket and we have a child ticket. And what we want to do is write an equation with more than one variable representing these tickets that would represent how much money we make. And the first question we should ask ourselves is how many variables are in this equation? And I think that, it becomes somewhat intuitively obvious when you read through this is that we have two unknowns, and these are going to be adult tickets and child tickets. As far as how much money we make, let's think about this. How would we be able to determine how much money we're going to make off of this event? And when one thinks about it, I suppose we could write this out. We could say, the revenue that we make, that we have, would be equal to what? Now let's think about this. I mean, if you wanted to find out how much money you make, we're going to have two different types of tickets. And I suppose that we're not going to charge the same amount for adults as we are going to charge for children. So what we'll do is this. We'll think about this. If, say, we charge $5 for an adult and $2 for a child, and we wanted to find out the total amount of money that we're making, what we would do is say, let's take $5 times however many adult tickets we sell, plus $2 times however many child tickets we sell. Okay. So in terms of writing the verbal model, it says, or we have here, it says the revenue that we would have would be equal to, let's say, the amount of money per adult ticket times the number of adult tickets, this is reasonable, plus the amount of money per child ticket times the number of child tickets. So when it comes to writing verbal models, what I want everybody to recognize right off the bat is this. And a lot of people, it's a confusing thing writing verbal models, but I want us to see that all we did was write out a plan for how much money we're going to make. Trust me, if you were running this event, you would have had this figured out right off the bat. How much money can I make from this? But from this verbal model, what I want to do is I want to write out now kind of an algebraic model. So instead of writing the revenue, for example, we say the revenue. Suppose we can underline this here. The revenue that we would have would be equal to, so we have equal to the amount of money per adult ticket, so we say amount of money per adult ticket times the number of adult tickets, and then we say plus the amount of money per child ticket times the number of child tickets. So what we're going to do now is kind of truncate this a little bit. We're just going to write this a little bit shorter. We say revenue is equal to the money per ticket, and let's write it this way. We say ticket, and we'll write adult. We take the money for an adult ticket, so money per ticket for an adult, times the number of adult tickets. Why don't we call this a letter like, I don't know, adult is capital A. So that'll represent adult tickets, number of adult tickets, plus now the money per ticket for a child, times the number of child tickets, and we'll just write a capital C. So from this, we can shorten it even further, and we can say, well, then the revenue, let's use a letter for this, we'll just call it R, is equal to the money per ticket for a child ticket times the number, the money for adult ticket times the number of adult tickets, plus the money for child ticket times the money of number of child tickets. So what we can have here is essentially this. We could say this is our algebraic model. R equals all of this. Where we would define these off to the side, we say R is revenue, C and A are, and this is important, number of tickets, child, and number of tickets. We have to say number of, otherwise we're thinking that the letter actually equals a ticket, and it's not a ticket, okay? With this model though, once we've written it and we have our equation here, what we can do is we can actually start to solve for some unknowns. You notice that we already listed our variables over here. Let's read through the second part of this, but it says, for our event, our goal is to sell $25,000 in tickets. Now we want to underline all important information, so we say $25,000 in tickets. We plan to charge $25.25 per adult and expect to sell 800 tickets, and that's adult tickets, okay? It says we need to determine what to charge for child tickets. So here's the deal. In terms of what we know already, let's go back to these numbers and say, well, which of these values are we already familiar with in our algebraic model? So for instance, revenue. We notice that this $25,000 right here, this represents revenue. So we're going to go ahead and we're going to write down the values for the things we already know off on the side, and we're going to talk about what we don't know. So revenue says we plan to charge $25.25 per adult ticket and expect to sell 800 tickets. So 800 tickets, we would say number of adult tickets, A, is equal to $800, okay? And then the other thing I want to say is price for an adult, okay? We'll write it this way. Price for an adult, we say, is $25.25. So now the question becomes this. We need to determine what to charge for a child ticket. So in terms of our model up here, we say revenue we know, okay? Adult tickets we know, the price per adult ticket we know. We want to find out how much to charge for an adult ticket. But what this does is it requires us to know R and the money per adult ticket and the number of adult tickets, but it also requires that we know the number of child tickets. So if we continue to read here, you'll notice here it says this. We need to determine what to charge for child tickets, but also this, how much should we charge per child if we expect to sell 200 child tickets to meet our goal? So we already know what we want in the end. We can now say this, we want to sell 200 child tickets. And now knowing this, we can actually substitute this into our equation up top, or our model. So we're going to do this now. We're going to do this for the event that we sell 200 child tickets, but we said our income, or our revenue rather, was $25,000, this is our R, equals the price per an adult ticket. Now we know this to be $25.25. We wrote that over here. So we say 25.25 times the number of adult tickets. So we say number of adult tickets. Sorry, I didn't mean to put a dollar sign on that. We want to sell 800 tickets. So we say 800 tickets. Plus now we say the price per adult ticket times the number of tickets. So we don't know the price. So we say price child per ticket times the number of child tickets, and we're saying that we have 200 of these. From this situation, what we're trying to obtain is, writing the model is the easy part. Now we're plugging in all the stuff we know and going and finding the one thing that we were asked to find, which is this. What should we charge for a child ticket? So what we want to do is we want to isolate this, which is really just solve an equation. Starting with, we need to simplify both sides. So I notice that the right side of this equation needs to be simplified. In this case, no distribution or combining like terms, but we have some multiplication. So 800 times 25.25, we can do this here. We say, all right, pull our calculator up. 800 times 25.25, and we get 2,200. Not 2,200, but 20,200. Plus now the price for a child times $200. So in order to get this by itself, it looks like we're going to have to subtract 20,200 from both sides. And what this is going to do, it's going to take out what we made off the adults, essentially. We say, all right, well, what if I took 200 away from this? I'm going to be left with $4,800 on the left here. And on the right side, we say this is equal to the price times 200. So to get the price by itself, what we're going to do is we're really going to divide both sides by 200 to get rid of this 200 here. So dividing by 200, let's talk about this. By the way, all we have left on the right is the price for a child ticket that we were looking for. And on the left, we can see that our 2 zeros dip out here, and 48 halves, that's the same as 24 wholes. So the last thing we want to make sure we do is label this answer. We want to write our answer as kind of a complete sentence. If I were to write an answer, I would put it this way. Well, if our goal is to make $25,000 and we're going to sell 800 adult tickets at $25.25 a piece, with also selling 200 child tickets, in order to meet our goal, we would have to sell child tickets for $24 per ticket. So you might consider this. What I want you to do is give this a shot on your own, but go back and do these again, and instead of using 200 child tickets, let's use 300 or 400. And what we're going to be doing is we're going to be putting that in for this value right here. And essentially, the question will become, how does that affect this situation? If I were to sell more child tickets, do I have to charge more per ticket or less per ticket in order to meet our goal? But that's working with a verbal model involving more than one variable.